Yo, what's good? These Celtics are in the NBA Finals right now. And today I'm gonna do something very special. Feed the latest foundation, seek Kubernetes. Kubernetes has become a very hot and very amazing topic regards to many different applications, such as container deployments and other types of really amazing things. So before we begin, I also want to thank the Boston Celtics beating the Miami Heat in 7 in the NBA Finals, and Ime Udoka and the amazing Celtics. They've worked really hard. And as a Boston sports fan, I really appreciate the hard effort and the tenacity they've shown. And in that spirit, also show the hard effort and tenacity for the rest of this Algos in 10. So not only will there be episodes being uploaded, there'll even be behind the scenes and some coding exercises for you guys to try as well. Without further ado, here are some Kubernetes questions for season 2 for the season 3. Oh, for episode 2 for season 3, sorry. There's so much excitement, I forgot which season it was. So yeah, let's continue and enjoy. So we have now basically Club Penguin. And if you have not played Club Penguin before, it's a fantastic old game with some great servers and great chats and lovely little penguins. One of my favorite mini games in Club Penguin and one of my favorite pastimes in any TV, like Northeastern Media Club and other types of activity, is to play the Pizzatron, where you have the penguin frantically making the pizzas for the Club Penguin group. So after merrily watching the Celtics win again, you're down to play some Club Penguin with your friends. Uh-oh, somebody has apparently hacked into Club Penguin accounts, and it's up to you to trust the Kubernetes gods and the Pizzatron 3000 to host pizza parties on your behalf. This problem set will be divided into 3 levels. Level 1 with the regular Pizzatron, level 2 with the candy Pizzatron, and a really cool divide and conquer with some decision trees and data science metrics for level 3. So let's kubectl apply -f clubpenguin.yaml and start to make some pizzas. So here's some rules for the Pizzatron game, which is very, very simple. You're allowed to make maximum 4 mistakes before you lose the perfect score for the Pizzatron game. And you basically earn Club Penguin stamps. And you can look at the link on your own time when you look at the Club Penguin. And of course, to make sure to follow CK80 integrity, none of these problems are from the CK80. They're all from my own personal invention. So we begin with level 1, regular Pizzatron. So before I talk about the Pizzatron, let me show you guys a little bit something about the Kubernetes. And of course, you can see I have a very, very lovely as you can see, I have a very, very lovely background here of the Boston Celtics. I have a very lovely background over here of the Boston Celtics and the Warriors NBA Finals, which is fantastic. So I turn up my terminal here. Let me make it a little bit bigger. Yep. Let me make this a little bit bigger so you can see what's going on. So first of all, to make sure you have all the pods you want in kubectl, you want to do kubectl get pods. That'll basically determine how many pods you've made. As you can see, I've been prepping quite a bit, so I had made like 1 million pods. So it's Flight Reactor says it's full of pods cheese, basically. But to make things more interesting, I could basically then do get kubectl get pod get namespace -a, which means get all the namespaces with Kubernetes. And I made some pretty solid namespaces in prior to the episode. So to begin this question, we first have 2 namespaces to set up. So I made 2 namespaces, orders Club Penguin and score Club Penguin, which are both active clusters, namespace clusters. Then for each of the ingredients, pizza sauce, hot sauce, cheese, seaweed, crayfish for some reason, squid, and shrimp, we make a Kubernetes deployment. And for each ingredient, we use 4 replicas, which is like the maximum amount of times you can mess up without losing Club Penguin pizza ticket. So if I look, for example, in one of my coding for the Pizzatron, I do vi pizzatron.yaml. So in Kubernetes, we use those awesome YAML files to basically make some to make some very basic Kubernetes deployments. So this is a very simple pod with a volume mount and a mount path of etc/kitchen. So here you want to make sure you have a deployment. So to do that, you get kubectl get deploy. And this will give you all the deployments you've made for Pizzatron. Since I have not ran any of them right now, none of them are ready, but I'm about to make them ready. So watch the magic of Kubernetes here. Watch the magic of Kubernetes here. So we have 4 replicas in regards to the deployment, which I just shown with kubectl get deploy. The replicas are not ready yet, but they will be. And then we finally have a config map named CM kitchen with the map path etc kitchen. So basically you want to have the relative path in Kubernetes, and you want to have a volume with the Pizzatron ticket. So make sure each component works correctly. So like use kubectl get ns for the namespace. You get kubectl get deploy for the deployments. And finally get kubectl get config map commands, or get cm for config map. It will show that you have the config map for CM kitchen. Awesome. So now make sure this thing actually works. I'm going to do the following. I'm going to do kubectl get pod -a to get all the pods available. And I'm going to show you the status. So for Pizzatron, it is running perfectly, which is fantastic. And for all the deployments, it has a little bit of an error because of image back pull off. So if you're like debugging Kubernetes, you want to know what the status is. You generally want the running status to have good time for Kubernetes. All right, level 2, Candy Pizzatron. This one gets a little bit harder, but it's also pretty fun. So you go back to kubectl get deploy for the get the namespace. For the 3 namespaces now we made, the max orders Club Penguin, the max score Club Penguin, and also just for funsies, the default Club Penguin. And then for each of these ingredients, we'll make Kubernetes containers with the following specs. You have to make them very carefully, just like the real Pizzatron game. You don't want like the hot sauce going to the wrong pizza and like somebody allergic to shrimp adding a shrimp. It's really common sense. So create a pod named Cookietron with the following containers. The container 1, you have the chocolate sauce with image Redis and command sleep10. So I'll show you guys where I got the Cookietron YAML file, which is a little long, but quite good. So you can see I have all the volumes on top, which I only had 2 volumes, the licorice persistent volume and the Club Penguin persistent volume. And by the way, if you want any help with Kubernetes coding, you can look at this awesome docs here, the Kubernetes.io docs, which is pretty bomb. I'll be putting this in the channel description, in the episode description. And now for container 2, we'll have pink icing with image Alpine and environment variable and Nginx port with value 8000. It's almost like a front and back end in terms of a port. So let me give you a quick picture of how this thing would work. So for the Nginx port, you basically have something called a front end and a back end. Later in the episodes in the season, we'll talk about the ingress and the networking services, which are quite difficult to understand. But for now, to keep things really simple, I'm going to do the following. I'm going to have one port here in Nginx. I'm going to have another port here that's like the server port for Kubernetes. So with this question, we basically have the port value 8000. So it's like basically a pointer to the 8000 HTTP port value. And then the server port, we say generally is around 3000. So this is just like by default. You could change it to any IPv4, IPv6 server port you want. And essentially here we have an Nginx connector to the server port here via IPv. 4. So if you're not that good at networking, I suggest you guys review some networking concepts here. And then we have an environment variable that connects from Nginx port to value 8000. So that means it's in this code over here. The env defines the environment variable for Kubernetes. And now we have container 3, which is name sprinkles with image redis and command ls-lart, which basically means like if you use Mac terminal, it basically lists out all the directories on your computer. So this is yet again another simple sprinkles with redis and the command ls-lart. Then for container 4, you got some pretty solid marshmallows with image alpine 1.2, an environment variable in Nginx port mapped to secret called marshmallow-secret. So this, you have to make sure you have a secret named marshmallow.secret. Now this is obviously a reference to the singer, to the artist Marshmallow, the guy with the marshmallow head. It's quite awesome to have that. So kubectl secret will get you there. And it's type opaque, which means it is a different type than the regular Kubernetes. You don't have to worry too much about types right now, just make sure it works. And then for container 5, you got named jelly beans with namage redis and command echo Pizzatron club penguin. So this echo command allows you to basically redirect a basic print statement, basic like command over to your terminal. And then container 6, you have named chocolate chips with image Nginx 1.4, an environment variable Nginx with value 8080. Move to persistent volume called club penguin-pv. So persistent volume is a form of volume in Kubernetes. And this we can do with the kubectl get pv command, which will get the persistent volumes. And finally, have named licorice or licorice if you're American, with image Nginx 1.5.1, amount to an existing persistent volume named licorice-pv with read-write many, storage 15GI, and ambassador design pattern. So we'll briefly review the design patterns of Kubernetes. So if you search on Google, there's basically 3 main design patterns in Kubernetes: the sidecar, the ambassador, and the canary deployment. So we're going to use the ambassador design pattern here. So essentially, the ambassador design pattern works as follows. You have essentially an ambassador value that is like delegated to your Kubernetes main pod. And it's sort of like a carryover from the original design, from the original Kubernetes design pattern. It's like a form of almost like a form of the distributed server between like the 2 types of containers. So if you look at the ambassador design pattern more carefully, you'll be able to like determine, it's sort of like the Harry Potter, like when he was with Hagrid in book 7 fighting off Voldemort. Like it was like the guy in the sidecar and then Hagrid like in the main car. It's sort of what the ambassador design pattern is. You have like a sidecar piece of code here that like links to the main car. And the other 2, the canary, is like when you basically have a design pattern of like a dead canary in a coal mine. Like you have some code does not work, you have a canary to back it up. And finally, you have the sidecar design pattern, which allows you to like connect another component to each other in the Kubernetes. We'll go over design patterns more succinctly in the later episodes, but that's like a general preview. And now finally, we get some CTCI review again. Chapter 4, problem 12. Pass with some. So the pizza shift is over, you better get paid. Since the economy in the Club Penguin, since that reflects the real current economy, which is not that great, we must make some financial decisions here. So we have the Club Penguin payday decisions. So essentially the payday decisions was as following. We're given a binary tree with certain nodes. They're either positive or negative. Positive if you obviously make the pizza well, negative if you mess up the pizza order. Each edge in the tree is weighted exactly as 5 for the 5 coins you earn in a regular Pizzatron level, or 10 for the Cookietron advanced level. The path you earn your money need not start from the root, but must traverse in a BFS, breadth first search, / DFS, depth first search fashion down to the child nodes. And you have a Gini impurity of each fork in the decision tree paths can vary between 0.0 and 1.0. For more information about Gini impurity, see here. Here's like an example. Let's say you made pizza 1 correctly, and pizza 1 correctly for both candy and regular. You made pizza 1 correctly again for the either made pizza 1 correctly for the regular, but you made pizza 2 incorrectly, or you made it the other way around, pizza 2 correctly, but you made pizza 1 incorrectly, or you made both of them incorrectly. Then you have the Gini of a pizza, which is 0.5. So you want to come up with an algorithm that gives you the maximum sum, the maximum pay of the Club Penguin coins from the number of paths that sum up to a payday of Gini impurity with more than 0.5. So give you guys a minute or two, or in Jimmy Butler's case, a few seconds actually before he hits a potential game-winning 3 to discuss this problem while I actually come up with my solution. And by the way, if you want to see the problem motivation, look at CTCI chapter 4, problem 12, pass with sum. All right, that's enough time to think about the problem. So before we do a problem, let's do a quick example of the problem. So you have like a root node here, you have another node here, you have another node here. This is a very simple binary tree. You have a line connecting the 2 paths. This is like a very simple data structure review. So if pizza 1 being made here, pizza 2 being made here, and then pizza 2 again being made incorrectly here. So if you make pizza 1 and pizza 2 correctly, you get basically a $5 bonus, $15 bonus. If you made one of them incorrectly, you get a -15. You basically lose your money because you made the pizza order wrong. So then let's extend it to a pizza 3, which is another pizza order. And if I do like a -5 because you made the pizza order wrong, that means you only have 10 for pizza 3. So you can see it, like it's basically a trade-off between making the right pizza, wrong pizza. This is a binary decision tree. With that being motivated, we can now start making our solution. So our solution is very simple. We essentially have one very simple algorithm that keeps track of the running sum of Gini impurity. So you have public int keep track path sum. And you have 5 variables. You have the read, you have the tree node root. The tree node is a structure that's defined outside in a Python class. Target sum, and you also have Gini impurity value. So within this function, you can do the following. You can essentially return a method. So return count paths with some Gini. So you have like the path sum with the Gini variable. And you have basically 4 parameters to return. You have the root, the target sum, a placeholder for 0 because you don't know which value you have yet for the total root, and then a new, well, they use hash map. We're going to actually use an array list. We're actually going to use the hash map as well with integer mappings. You have integer mappings here in Java pseudocode. So that's your first method. Now your second method goes as follows. Your second method is now going to become the counting method. So it's almost like a DFS, BFS parody. So you have running sum here. So you have the count paths with some Gini. You can also do this in Python as well. You can also use like Python construction classes and like dot self init to also do in Python. But I think Java will be easier because you don't have to declare that many constructed variables. So you then have a tree node, int target sum, int running sum, you have like an accumulator. And you have also a path count, which is going to have hash map integer. So you have a hash map that has like a path count for each pizza value, each pizza order you do right and wrong. And of course, you have the Gini sum here. Whoops. Of course, you have the Gini sum here. So I'm going to sort of make this thing a little, oh my, okay, sorry. Make this thing a little bit longer. So I could add more space. Excellent. So for this problem set, you first determine the following. You first determine if you even have any orders. So if no orders, this returns 0 because you have nothing to do. Or this is the base case. You also have orders as actually the number of orders of pizza you have. Also, if node equals null, you also return 0. It's another base case. So it's a recursive function here. Otherwise, you have the sum. So you have the running sum equals node.data. So you specify the data of the node. You then have Gini equals to the calculated Gini impurity. So you have a Gini impurity function that will calculate the Gini given the root, the node, and the current value, which is the target sum. You calculate the Gini impurity. Then you have a general function sum, which is the absolute difference of running sum, because you can't have negative money in Club Penguin or in real life. Running sum and target sum. And then you finally have this. So if the running sum and target sum the same, and the Gini values match between two nodes, then you can basically increase the paths. You can increase the paths here, or paths plus equal 1. Otherwise, I'm going to move this thing a little bit up here, actually. Otherwise, you can increment recursively. So you can then do a very simple increment value. So we can do increment the hash table with essentially 4 parameters. You have the path count. You then have the running sum, and you start from 1, and you have the Gini value given to you. You have the Gini value. You can then increase total paths with the count path sum of the left node the target sum, the running sum, half count, and the current Gini value. And of course, you can then do it for the right-hand side, the left-hand side as well, because it's a binary tree of the left tree and the right tree. So I'm going to copy paste that, or just retype it. Increase total paths with the count path sum, right-hand node target sum, running sum, path count, and Gini. And then of course you decrement by 1 because you're trying to run down a hash table here. So increment hash table, path counts, running sum, -1, and then of course the Gini value you're trying to determine. And you can return the total paths. So that's it for this function over here. Now if I scroll down, I have yet another function to do. And that's going to be the increment hash table function. And that's going to be a little more complicated. So we have public void increment table. We have the hash map of integer. Now this is a lot better than the brute force, which is basically like keeping, you know, every sum in like a table and trying to like count, because brute force is not very good. And key int change, you have to change a bit, and also you have the Gini. So in this case, the new count is basically get the default key from the tree and add to change. If the new count is 0, sorry, if the new count 0, you then set the Gini back to 0 because you're restarting from the tree. And then you also remove key from hash table. Hash table is efficient because you have O1 work, which is pretty good. Otherwise, you put the key in hash table and update the Gini value. There you go. There's your very simple pseudocode for this algorithm. So I will definitely show you the solution, the full coding solution later in good time. And also, hopefully, we continue enjoying the Celtics winning the NBA Finals and continue enjoying Club Penguin. If there's actually a lot of more time, I'll also play a game of Club Penguin and show you guys on my YouTube channel. So yeah, this is Algos and 10, Season 3, Episode 2 with Jason Liu. And of course, go Celtics. So yeah, that's it. That's it for the episode. Really enjoyed this amazing run from the Boston Celtics. I also really enjoy learning some Kubernetes, a new skill that was very useful for DevOps and reviewing some solid tree structures. So episode 3 will have the new game Wordle, which is going to be a very interesting OOP design and more Kubernetes fun. So yep, see you guys then. Bye.